Quick pause. If you prefer the hard numbers and true engineering of superyachts over just looking at glossy brochures, hit the subscribe button right now.
Welcome to the deep dive. Today we are taking a little bit of a detour. We are shifting gears entirely.
Yeah, we are. A pretty massive detour, honestly.
Right. We're leaving the abstract world of software and economics for a moment to look at something very tangible, something massive, and frankly, something that I think most people completely misunderstand.
I agree completely. I mean, usually when the world looks at the superyacht industry, they just see the vanity metrics.
Right, the spectacle of it all.
Exactly. They see the gold taps, the infinity pools, the paparazzi shots of celebrities in St. Tropez or, huddled under umbrellas in Monaco. It gets treated as pure spectacle, just a symbol of excess.
It's very easy to dismiss it as just toys for the ultra-rich.
Yep.
But if you actually peel back the layers...
And ignore the silk cushions for a second.
Yeah, ignore the cushions, look at the steel. What we are really talking about is high-stakes industrial engineering. I mean, we are talking about complex market strategies that rival anything you'd see in the tech sector. And honestly, some of the most sophisticated naval architecture on the planet.
It is a fascinating duality. You have this asset class that is universally perceived as a frivolous toy. But to build one that retains its value and can actually cross an ocean safely in a force 9 gale, that requires a level of precision that honestly rivals the aerospace industry.
And that is exactly our mission today. We're going down the rabbit hole to deconstruct the Dutch shipyard Amels. But we aren't just reading you the marketing brochure.
No, definitely.
We are analyzing the evolution of the shipyard through the lens of 3 very specific, very different vessels. We've got Here Comes the Sun, Gene Machine, and Entourage.
These 3 boats are perfect case studies because they represent 3 completely different engineering solutions to the exact same problem, which is how do you balance luxury, seaworthiness, and liquidity?
Liquidity is a really key word there. We are going to look at how physical engineering choices, things like extending a hull or installing hybrid propulsion, how those directly impact the financial performance of the asset.
Right, because you have the massive refit of Here Comes the Sun. You've got the proven bulletproof platform of the Amels 180 with Gene Machine, and then the hybrid future with Entourage.
It's basically the past, present, and future of Dutch steel, all woven into one narrative.
It really is.
So let's start with the context for you listening. Amels isn't a custom yard in the traditional sense, right? They pioneered something called limited editions.
They did, and it completely changed the economics of the entire industry. I mean, before Amels introduced this concept, you essentially had 2 choices as a buyer. You bought a production boat, which was usually fiberglass, smaller, churned out of a mold.
Right.
Or you went full custom.
And full custom is the romantic idea, isn't it? You sit down with a naval architect, you sketch a profile on a napkin over dinner, and you build a dream.
It is very romantic, but it's also a total nightmare of logistics. Full custom means you are designing every single doorknob, you wait 5 years, and critically, you just have to pray it floats the way you want it to.
Because it's a one-off.
Exactly. You are paying for the R&D of a prototype. You are the guinea pig for all the engineering bugs.
So Amels, which is under the massive Damen Shipyard's umbrella, they look at this and said, there has to be a better way to do this.
Yeah, they realized there was a third way. They took commercial shipbuilding principles. So standardized hulls, standardized engineering platforms, standardized engine rooms, but they allowed for custom interiors and custom superstructures.
Okay, so you get the reliability of a commercial ship, keeping in mind Damen builds tugs and offshore patrol vessels and warships.
Right, heavy-duty stuff.
But you get the finish of a superyacht on top of it.
And you get it in half the time. A buyer can step in halfway through the build. That is the limited editions philosophy in a nutshell. And that philosophy is the thread that connects all 3 of the boats we are diving into today. Ultimately, it's about risk mitigation.
Let's jump right into the first case study then. This is the heavyweight, Here Comes the Sun. This boat has been all over the industry news recently.
It has. So January 2026, it was confirmed sold in international waters off Barcelona, and the asking price was 165 million euros, VAT paid.
That is just a staggering number.
It is.
But what makes it even more interesting is the timeline of the boat itself. This vessel was originally delivered back in 2017.
Correct. And usually if you have a boat that is almost a decade old, it would be depreciating. It's an aging asset. But the context here is everything. This wasn't just a standard brokerage sale. It was the market validation of a massive engineering gamble.
Walk us through that gamble.
So the boat was originally delivered at 83 meters long. It was the Amels flagship. But in 2021, the owner took it back to the shipyard and essentially said it's not big enough.
Now, for most people, if your 83-meter yacht isn't big enough, you sell it and you buy a 90-meter yacht. You don't usually decide to perform major surgery on the existing hull.
No, you don't. But that is exactly what they did. This wasn't a refit where they changed the carpets and painted the radar mast. This was a total rebuild. They essentially cut the yacht in half.
I really want to pause on that image for a second. Cut in half. How does that actually work in reality? You have an 83-meter steel structure floating in the water. You can't just take a saw to it.
It is a logistical ballet. It's incredible to watch. First, you have to bring the vessel into a massive dry dock. You pump the water out, and you have to support the hull on keel blocks perfectly, and I mean perfectly, aligned to the keel.
Because if it sags even a fraction of an inch,
the whole structural integrity is compromised.
Yeah.
Exactly. Then they have to meticulously mark the cut line. This involves laser precision, because you aren't just cutting the outer steel shell, you are cutting through structural transverse frames. You're cutting miles of piping, electrical cabling, HVAC ducting, everything.
all the arteries of the ship.
Right. And once the cut is finally made, they use these heavy-duty hydraulic skids to slide the front half of the ship, the entire bow section, forward by exactly 6 meters.
That just sounds terrifying.
It's wild. You literally have half a ship just sliding away on rails. And then they take a crane and drop a brand new 6-meter steel section, which is a prefabricated mid to aft block, right into that gap.
And then you have to weld it all back together, which I imagine is where the metallurgy comes in.
Huge metallurgical challenges. You are marrying old steel, well, 2017 steel, to brand new steel. The metallurgic properties have to match perfectly. The welding process creates heat distortion, so they have to manage how the metal warps as they weld the seams.
Oh.
And perhaps the most critical part is the propulsion shafts. The engines are in the middle, the propellers are at the back. You've just added 6 meters to that distance. If the alignment of those steel propeller shafts is off by even a millimeter over that new 89-meter length, your shafts will vibrate.
And vibration is the enemy.
It's the ultimate enemy. It will burn out your bearings, it will destroy the gearboxes, and the boat becomes an unlivable nightmare. The tolerances they're working with are microscopic on a macro scale.
It sounds incredibly risky and stressful. Why go through that massive headache instead of just commissioning an 89-meter boat from scratch?
Time. It always comes down to time. Building a fully custom 89-meter yacht takes 4 to 5 years, maybe more if the yard has a backlog. This entire rebuild took 12 months.
Oh, wow.
Yeah. In the world of billionaires, time is literally the only commodity you cannot buy more of unless you do something crazy like this.
So they successfully extended it to 89 meters. But I am super curious about the naval architecture side of this. I assume if you take a boat that was specifically designed hydrodynamically to be 83 meters and you stretch it, you mess up the math. Doesn't adding that much hull make the boat slower or less fuel efficient? You're dragging a lot more steel through the water.
You would naturally think so, yes, because you are adding wetted surface area, and more surface area increases what we call skin friction. But naval architecture is often deeply counterintuitive. By lengthening the hull, they actually increase the overall efficiency of the vessel.
Okay, you have to explain how that works.
It comes down to a principle called the Froude number, and specifically wave-making resistance.
Break that down for us.
So a displacement hull, which is what these big steel yachts are, they don't plane on top of the water like a speedboat. They push through it. And as the boat moves, it creates a wave system. A wave at the bow and a wave at the stern.
Right, you always see that big wake.
Exactly. Now, a hull is limited by its waterline length. The longer the waterline, the further apart those bow and stern waves are. When you lengthen the boat, it essentially becomes slenderer relative to its overall length. It slips through that self-generated wave system much easier.
So the energy required to push the water out of the way actually drops?
Yes. The reduction in wave-making resistance was so significant that it more than offset the penalty of the added skin friction from the extra steel.
So it's actually more fuel efficient per ton of displacement now than it was before the cut?
Correct. The current stats on Here Comes the Sun are just phenomenal. It has a range of 10,000 nautical miles, cruising at 10.5 knots.
10,000 nautical miles. That is immense.
It's globe-girdling capability. You could cross the Atlantic Ocean, turn around, and cross it back without ever stopping for fuel.
That is incredible engineering. But what about the balance of the ship? We touched on this in our prep notes for the episode, the deep dive, the center of gravity problem. You are adding steel, a massive pool, new decks, all of that weight is biased toward the back half of the ship.
This is where Azure naval architects really earned their fee. They were the original designers of the hull, and it was a very smart move by the owner to bring them back for the rebuild. If you add hundreds of tons of weight to the stern, the bow naturally wants to lift out of the water.
Right, like a seesaw.
Exactly, you lose your longitudinal trim. And a boat that squats by the stern is incredibly inefficient. It drags water, it ruins the hydrodynamics we just talked about, and it's terribly uncomfortable in a seaway.
So they had to reballast the entire vessel, add lead to the bow.
They had to recalculate the entire stability curve from scratch. They adjusted tankage, ballast, everything. But it's not just the static weight that's the issue, it's the dynamic stability.
Meaning how it handles waves.
Right. The yacht uses quantum zero-speed stabilizers. These are massive underwater fins that articulate like airplane wings to stop the boat from rolling side to side, even when it's just sitting at anchor.
I've seen those. They're huge.
They are. And those systems are highly tuned to the specific natural roll period of that exact hull shape and weight distribution. When you change the length and you change the mass, the roll period of the ship changes entirely. So they had to completely recalibrate the software and the hydraulics of the stabilization systems to ensure the boat didn't just wallow uncontrollably in the swells.
And you mentioned the new amenities. They didn't just add empty deck space. They put in a 7-meter swimming pool.
A flush deck swimming pool. This is a very critical distinction in yacht design.
Meaning the water level is flush with the teak deck. It's not a raised tub sitting on top of the deck.
Right. Which means the physical tank for that pool is hanging down inside the hull structure, taking up space below deck. Now, salt water weighs a metric ton per cubic meter. A 7-meter pool holds a vast amount of water. That is a massive static load sitting right at the stern.
But I'm guessing the real danger isn't just the weight itself.
No, the real danger is what naval architects call the free surface effect.
I remember this term from physics class, but explain it for us in the context of a ship.
Imagine you are holding a flat baking tray full of water, and you start walking across your kitchen.
It immediately starts sloshing back and forth.
Right. And as that water sloshes, its weight shifts rapidly from side to side, and that shifting momentum actually pulls your arms. It amplifies your own movement. On a ship, if you have a massive tank of water that isn't completely full to the brim, or even if it is but the boat is rolling, that water moving side to side can violently destabilize the vessel.
It creates a pendulum effect inside the ship.
A massive internal pendulum. There are actual cases of commercial ferries capsizing entirely because of the free surface effect from water accumulating on the car deck. So a 7-meter pool on a yacht is an engineering nightmare.
So the structure around it has to be incredibly robust.
They had to build a structural cofferdam, essentially a heavily reinforced steel box entirely surrounding the pool tank to isolate those dynamic sloshing forces from twisting the main hull frames. And to add to it, this specific pool has contraflow jets, so the guests can swim against a current.
Which means massive, high-capacity pumps.
Massive pumps, complex plumbing, and a ton of added mechanical vibration right above the guest cabins. It is a packaging and engineering marvel to make that silent and safe.
It really is like building a whole new boat and surgically attaching it to the old one.
And they didn't stop at the water level either. They went up. They added a second helipad.
Yes, up on the sun deck. They extended the overall length of the sun deck by over 3 meters just to create a fully certified commercial landing area. Why on earth do you need 2 helipads? It seems excessive even for the billionaire world.
It comes down to logistics and redundancy. The original pad, which is on the bow, on the foredeck, is what they call a touch-and-go pad.
So you land, drop people off, and take off again. You can't park there.
Exactly. But if you want to actually park a helicopter, say a big twin engine like an EC-145 or a Bell 429, you need a dedicated deck. Having 2 allows them to have one chopper parked semi-permanently on the roof, while another one can still land on the bow to drop off guests. Or you can keep the primary helicopter safe high up on the upper deck, away from sea spray, while using the foredeck for loading supplies.
But landing a multi-ton helicopter on the very top deck of a ship that has to introduce a massive amount of impact force incredibly high up on the structure.
That is the vertical center of gravity challenge, or VCG. You are putting extremely heavy machinery at the absolute highest point of the ship, which is structurally the worst possible place for stability. It makes the boat top heavy.
And a helicopter isn't just a static grand piano sitting there. It lands.
Right. It arrives. It drops out of the sky and slams down. The dynamic load of a 3-ton machine hitting the deck requires massive structural pillars running vertically all the way down through the superstructure to transfer that shock load directly into the steel hull.
You can't just bolt some thicker aluminum to the roof.
No, you have to strengthen the columns running through the walls of the master suite and the dining room 3 decks below.
It's cascading engineering. The owner says, I want a helipad, and the shipyard says, okay, we need to rip out the dining room walls 2 decks down to put in steel I-beams.
Exactly. And this intricate web of engineering brings us right back to the market value. Why did this boat just sell for 165 million euros?
Because even though the asking price dropped from 185 million, 165 million is still a massive premium for a hull that was originally laid down in 2017.
It sold for that much because the rebuild completely erased the aging factor. The buyer who just wrote that check didn't see a 2017 boat. They saw a state-of-the-art 2021 boat with a 2026 immediate delivery status. It was a turnkey masterpiece.
You get to skip the 5-year wait line.
Precisely. And it had the ultimate stamp of approval. It won Best Rebuilt Yacht at the World Superyacht Awards.
That award actually matters to the market.
It is crucial. It signals to the brokerage market and to insurers, look, this wasn't some hack job done in a cheap yard. This is verified, certified naval engineering. It completely mitigates the risk for the buyer. They aren't buying a Frankenstein monster. They're buying a globally recognized, prize-winning asset.
So here comes the sun, proves that you can radically surgically transform a platform if the baseline engineering is good enough.
Absolutely.
But let's pivot here, because sometimes you don't need to change the platform at all. Sometimes the platform itself is the entire point. Let's talk about our second case study, Gene Machine.
Ah, the Amels 180. I like to call it the Ford F-150 of the superyacht world.
I really love that analogy. It implies immense utility, absolute reliability, and ubiquity. You see them everywhere.
And that is exactly what it is. Amels delivered 25 units of the Amels 180 design between 2012 and 2020. In superyacht terms, where everything is usually a one-off, delivering 25 identical hulls is mass production.
Why was it so wildly successful? Why did 25 different billionaires decide they wanted to buy the exact same boat as the other guys?
Because it just works perfectly. It is 55 meters of steel displacement hull that hits the absolute sweet spot for usability. It's just under the size limit to fit into the prime, highly coveted berths in places like St. Tropez and Port Hercules in Monaco, which are often heavily restricted to boats under 60 meters.
So it's big enough to cross oceans, but small enough to actually park at the best restaurants?
Exactly. It has transatlantic range, and critically, because there are 25 of them out there, every single engineering bug, every squeaky floorboard, every rattling vent was ironed out by hull number 3.
So if I step up and buy hull number 20, I know for an absolute fact that the air conditioning won't rattle when I'm trying to sleep, and the plumbing will work flawlessly.
Correct. The risk is 0. And that predictability creates unparalleled liquidity. As we saw in the market notes, the Amels 180 is considered literal liquid gold on the brokerage market.
Talk to me about the financial numbers on these.
These boats trade in a very, very tight, predictable band, usually between 28.8 million and 40 million euros, depending on the interior and the year. They routinely retain 70 to 75% of their original retail value, even after a decade of heavy use.
That is basically unheard of in luxury assets. Usually, depreciation on a yacht is a sheer cliff the moment you launch it.
It is. But the Amels 180 is a known quantity. Charter brokers love them, crew know exactly how to run them, and investors love them because the maintenance costs are highly predictable. The parts are standardized across the fleet. You get reliable charter income in the Mediterranean in the summer and the Caribbean in the winter.
Now, Gene Machine, which is the specific 180 we are looking at, is a very special case because the owner, Dr. Jonathan Rothberg, is not your typical yacht owner drinking champagne in Monaco.
No, not at all. He is a brilliant scientist. He's the inventor of high-speed DNA sequencing. And he treats this boat as a functional tool. This isn't just a floating cocktail lounge for him. Gene Machine has been to Svalbard, up at 81 degrees north latitude, in the ice.
And it did a full circumnavigation recently.
Yeah, in 2023, combined with its support vessel, they covered almost 70,000 nautical miles.
70,000 miles. That is astonishing usage. Most white boats sit tied to a dock in a marina. 90% of their lives.
Gene Machine is a true hardcore explorer, and this is where the underlying engineering of that Amels 180 platform really shines. It's powered by twin MTU diesel engines. These are absolute industrial workhorses. They are designed for commercial shipping to run continuously for thousands and thousands of hours without missing a beat.
The fact that this boat can handle freezing Arctic ice conditions 1 month and tropical equator heat the next without constant mechanical breakdowns is a massive testament to the build quality.
It is. But the most fascinating thing about Gene Machine isn't where it goes, it's the interior modification Dr. Rothberg did, the science lab.
Right. He built a lab on the boat.
He completely converted the Sky Lounge. On a normal Amels 180, the Sky Lounge is the upper deck salon. It's a relaxation space. It usually has a wet bar, a massive TV, maybe a poker table. He ripped all of that out and installed a fully functional, state-of-the-art biological laboratory.
And just to be clear for the listener, this wasn't a prop for PR. They did real, rigorous science in there.
Groundbreaking science. During the COVID-19 pandemic, they developed a rapid home test kit called Detect right there on the boat. His daughter actively used the lab to sequence the DNA from unknown microbial life they discovered in the Arctic waters during their expeditions.
Think about the pure engineering requirement to make that possible. Things like DNA sequencers and scanning electron microscopes are incredibly sensitive to vibration. If the floor is humming or shaking even microscopically from the diesel engine spinning below, you can't get accurate data. The lasers misalign.
That is the ultimate stress test for any shipyard's acoustic and vibration engineering. The noise and vibration dampening on the Amels 180 platform is exceptional. They use complex, flexible double mountings for the engines, they isolate the generators, and they use extensive acoustic insulation inside the bulkheads.
It's basically floating rooms inside floating rooms.
Exactly. The fact that you can run high-precision, sub-micron lab equipment while the ship is physically underway, bashing through waves at 12 knots, tells you that the structural resonance of the steel hull is almost practically non-existent.
It's genuinely impressive. But Dr. Rothberg eventually ran into a bottleneck. He ran out of space. And instead of pulling a "here comes the sun" and cutting the boat in half to extend it, he chose a totally different strategy. He bought a second boat.
Gene Chaser, which is a Damon yacht support vessel.
Explain this concept to us. The shadow vessel or the support yacht. It's becoming a huge trend.
It's brilliant. It is effectively a heavy-duty commercial ship hull. Very fast, very rugged, huge open decks, but it's painted and faired to look like a yacht. It literally follows the main yacht around the ocean. It carries all the heavy toys, the deep-sea submersibles, the extra-large tenders, the spare parts, helicopter fuel, and the extra staff.
So Gene Machine gets to stay pure, uncompromised luxury and science. And Gene Chaser does all the ugly heavy lifting.
Exactly. Dr. Rothberg wanted even more lab space, and he needed cabins for visiting scientists and researchers. Instead of cluttering up Gene Machine or putting it out of commission for a 2-year refit, he just bought Gene Chaser basically off the shelf. It perfectly demonstrates the scalability of the Amels and Damon ecosystem. You want more capacity, just plug in a new module.
It also completely separates the operational noise from the owner. You don't have massive hydraulic cranes launching 30-foot tenders right outside your bedroom window at 8 in the morning.
Right. It is the ultimate luxury. Absolute silence and infinite space.
Speaking of silence and looking at the future, let's move to our third and final vessel today. The Amels 180, as legendary as it is now officially out of production. It has been replaced by the next generation, the Amels 60. And our case study for this platform is a yacht named Entourage.
Entourage is a perfect glimpse into exactly where the super yacht market is heading. Visually, it is a massive shock to the system if you are used to the old 180. The 180 was penned by Tim Haywood. It had very classic, sweeping, flowing, feminine curves. The ML60 is designed by Espen Oeino. It is radically different. It's angular, geometric, almost aggressive.
Yeah, looking at the photos, it looks almost military, like a stealth ship.
It is intensely modern. And critically, it is significantly bigger in terms of internal volume. The Amels 180 is about 671 gross tons. The ML60 is 830 gross tons.
Wait, help the listener out here. The new boat is only 5 meters longer, 60 meters versus 55 meters, but the volume jumped by over 20%.
This is a common point of confusion. Gross tonnage, or GT, has nothing to do with the physical weight of the ship. It is a volumetric measurement of the enclosed internal space. 1 gross ton equals 100 cubic feet of enclosed space.
Oh, okay.
So yes, the Amels 60 is a much fatter, taller boat. It carries its beam further forward, the sides are straighter, and the ceilings are higher. You get a massively larger living space in a hull that can still squeeze into those same restricted marina berths we talked about.
Now, there is a very specific, fascinating engineering story with Entourage regarding the windows. I saw the architectural photos in the notes. The glass is just massive.
Oh, the window problem. This is a legendary example of an owner's aesthetic desire crashing headfirst into structural reality. The standard off-the-shelf Amels 60 design, like the very first hull they launched called Come Together, it features large but distinctly trapezoidal windows, geometric cutouts.
Right.
But the owner of Entourage looked at that and said no. He wanted an entirely uninterrupted panoramic view. He demanded floor-to-ceiling, continuous strips of glass running the entire length of the main deck.
I mean, it sounds beautiful. Why is that such a massive problem for the shipyard?
Because the superstructure of a yacht, the big white part built above the main deck, isn't just a shelter to keep the rain off the surface. It acts as a massive structural girder. It provides vital longitudinal stiffness to the entire ship.
Okay, so when the ship goes over, a huge ocean swell.
The steel hull wants to bend. It wants to hog, which is bending up in the middle when you're perched on a wave crest, or sag, bending down in the middle when you're spanning two waves. The superstructure acts like the top flange of an I-beam to resist that bending force.
And if you cut a giant, continuous horizontal hole in the side of that girder to put in fragile glass,
You have completely compromised the structural integrity of the box. Glass obviously does not carry shear load. So to give the owner those continuous ribbons of glass, the naval engineers had to completely rethink the internal framing of the ship.
how do you fix that without putting the metal back?
They had to massively beef up the mullions. Those are the vertical pillars between the glass panes. And they had to heavily reinforce the deck headers above the glass and the deck floors below it with high tensile materials to compensate for the missing aluminum skin on the sides.
So a seemingly simple interior design choice required probably thousands of hours of structural finite element analysis.
Absolutely. And it likely added significant localized weight to the structure, which then immediately brings us right back to the center of gravity and stability recalculations we talked about with Here Comes the Sun. Every single aesthetic choice on a ship has a cascading engineering cost. But I will say, the final result is spectacular. The main salon is entirely flooded with natural light. It feels like a high-rise penthouse in Manhattan, not a cave on a boat.
And that modern interior feel is heavily reinforced by the design studio they chose, right?
Yes, Bertafleck. They are a highly acclaimed Canadian design studio, but they are known for designing W hotels and ultra-luxury retail spaces, not boats, and you can instantly tell. Traditional yacht interiors have a very specific vernacular. Lots of highly polished, glossy wood veneer, gold trim, and they always have these decorative recessed domes in the ceilings.
What is with the ceiling domes on yachts? You see them everywhere.
It is an old boat builder's trick. They use the domes to cleverly hide all the bulky HVAC ducting, the fire sprinklers, and the recessed lighting, while still creating an optical illusion of ceiling height in the center of the room.
Ah, that makes sense.
But the owner of Entourage hated them. He wanted perfectly clean, flat architectural ceilings, like a modern home.
Which, ironically, is significantly harder to achieve on a ship.
Much, much harder. You have to meticulously route all that thick air conditioning ducting, miles of wiring trays, and the high-pressure fire suppression pipes through much, much tighter void spaces because you no longer have that convenient drop dome to hide it all in. It required incredibly disciplined 3D CAD coordination between the interior fit-out carpenters and the technical mechanical engineers.
But the real headline for the Amels 60, the thing that changes the game, isn't the windows or the flat ceilings, it's the propulsion room. This is a true hybrid yacht.
It is. And hybrid is a marketing buzzword that gets thrown around very loosely in the marine industry. Often it just means a bigger battery. But Amels has implemented a deeply integrated, incredibly clever system. It offers 4 distinct operational modes.
Let's walk through these 4 modes carefully, because this gets technical, but it is absolutely crucial for understanding the future resale value of these assets.
Okay. Mode 1 is silent cruising. This is pure electric drive. The massive main MTU diesel engines are completely shut off. You are running solely on a massive lithium-ion battery bank that is driving electric motors attached directly to the propeller shafts.
How fast can you actually push an 830-ton chunk of steel on just batteries?
Up to about 7 knots. So it's not meant for open ocean crossing. It is specifically designed for leaving the harbor at 6 a.m. You glide off the dock completely silently. There is no deep engine rumble shaking the hull. There is no toxic diesel exhaust smell blowing over the aft deck. You don't wake up your guests, and you don't annoy the neighbors parked next to you in the marina.
I call that ghost mode. Just slipping away in the dark.
It really is. It's incredibly elegant. Mode 2 is called eco cruising. This is your standard, everyday, long-distance transit mode. You fire up the main diesels to turn the propellers, but they also run what's called a PTO, a power takeoff.
Explain exactly how a PTO works.
Think of it like an enormous alternator attached to the main engine gearbox. The main engine is spinning the propeller to push the boat, but it is also simultaneously spinning this generator that creates all the electricity needed for the hotel load.
The hotel load being the lights, the air conditioning, the galley ovens.
Right. Everything that keeps the humans alive and comfortable.
So you don't need to run a separate dedicated diesel generator down in the engine room.
Exactly. Normally, a yacht underway runs the 2 main engines for movement, plus 1 or 2 loud generators just to keep the lights on. That is 4 separate diesel engines burning fuel and creating noise. In eco mode, you just run the 2 main engines. Because they are loaded up heavily by both the propeller and the PTO, they actually run at a much higher thermal efficiency. They burn the fuel more completely. It is vastly more efficient for crossing an ocean.
Okay, that makes sense. What is mode 3?
Mode 3 is full power. You are late for a lunch reservation in St. Tropez. You engage the main engines to the max. You fire up the generators to add massive electrical power directly into the shaft motors. And you can even dump the battery bank power in as well. Everything pushes at once. That gets you to your top speed of 15.5 knots.
It's the push-to-pass boost button.
Right, maximum thrust. But mode 4 is the one that is arguably the most brilliant from a pure mechanical engineering standpoint. It's called peak shaving.
This sounds like a term stolen from municipal energy grids.
It is the exact same concept, just scaled down to a ship. Imagine you are sitting at anchor in a bay. You are running 1 single diesel generator to power the boat. It is happily chugging along at, say, 50% load, nice and efficient.
Yeah.
Suddenly, it's 7:00 p.m. The chef turns on all 4 high-draw induction ovens to cook dinner. The guests get back from swimming, so the jacuzzi heater kicks in, and the sun just came out from behind a cloud, so the automated air conditioning system ramps up to max power.
The electrical demand on the boat just spikes massively.
A huge instantaneous spike. On a normal, traditional boat, that single generator would suddenly bog down under the load. It would spew black, unburned, soot out the exhaust. The voltage might drop and flicker the lights, and the power management system would have to frantically auto-start a second cold generator to help take the load.
And that start-stop cycle has to be terrible for the machinery.
It's the worst thing you can do to a diesel engine. It causes thermal shock, massive wear and tear, noise, soot on the teak decks, and what we call wet stacking inside the cylinders.
So how does the peak shaving mode actually fix this problem?
The massive lithium battery bank acts as an instantaneous buffer. When that massive power spike hits from the ovens and the AC, the batteries instantly dump power into the grid to flatten the demand curve. The generator doesn't even feel the spike. It just keeps happily running at its perfectly efficient 50% sweet spot.
Oh, wow.
And then later, when the demand drops back down, the generator slowly recharges the batteries.
So it completely protects the mechanical machinery from human behavior.
Yes, it reduces mechanical maintenance costs significantly. It saves thousands of gallons of fuel. It makes the whole onboard experience completely silent and smooth because there are no generators constantly starting and stopping. And crucially, it vastly increases the operational range. The Amels 60 has a quoted range of 3,500 nautical miles, but if managed properly in these eco modes, it can push significantly higher than that.
And surely this heavily future-proofs the boat for the resale market, right?
100%. Global maritime regulations are getting tighter by the month. There are emission control areas, ECAs popping up everywhere now where you legally have to run clean. Certain pristine fjords in Norway are outright banning diesel emissions.
So you need the batteries just to visit certain places.
Exactly. Buying a massive diesel-only yacht today is rapidly becoming a bit like buying a luxury car without Bluetooth or a backup camera. It just feels technically dated the moment you drive it off the lot. Hybrid architecture is absolutely the new baseline starter for protecting your assets' liquidity.
So if we pull back and look at the whole picture of these 3 distinct vessels, we have Here Comes the Sun, the radically transformed giant. We have Gene Machine, the incredibly reliable globe-trotting mechanical workhorse. And we have Entourage, the sleek, high-tech hybrid of the future. what is the grand synthesis here?
The ultimate synthesis is the sheer power of the platform strategy. Amels realized early on that by creating a hyper-robust, completely standardized technical foundation, they could mathematically de-risk the ownership experience for the ultra-wealthy.
It's a massive financial safety net.
It really is. Gene Machine proved that the baseline platform works flawlessly mechanically and holds its financial value over a decade of brutal use. Entourage proves that the platform can successfully evolve to accept bleeding-edge technology like hybrid drives and radically new architectural designs like those massive windows. And Here Comes the Sun proves that even 10 years later, the structural platform is so inherently robust that it can be radically surgically altered to remain the flagship of the fleet.
It's an incredibly compelling argument for the limited editions business model over taking the plunge on a full custom build.
Yeah.
You aren't constantly reinventing the wheel with every single boat. You're just engineering significantly better rims to put on it.
Exactly. And for the listener joining us today, that is the core takeaway. When you look at these massive assets, don't just look at the glossy paint job or the interior decor. Look at the underlying hull series. A well-engineered, standardized platform is a highly liquid financial instrument just as much as it is a luxury toy.
I do have one final, somewhat provocative thought to throw at you. We know there are 25 of these Amels 180s currently floating around the world. They are deeply beloved, they hold their value, but they are strictly old-school diesels. And the world is rapidly going hybrid. Do you think we will start to see a super yacht rest-a-mud movement?
Oh, that is a fascinating question. You mean, will we see owners of these classic Amels 180s taking them back to the Dutch shipyards, not to chop them in half and extend them, but to gut the engine rooms, rip out the old MTU diesels, and retrofit them with the advanced hybrid systems we see on the Amel 60?
Yeah, it makes perfect sense, right? You absolutely love the lines of the boat, you love the proven hull,
Yeah.
you want the green tech and the silent cruising.
It would be astronomically expensive to re-engineer an existing engine room like that. But, as we clearly saw with Here Comes the Sun, these owners are more than willing to spend tens of millions of euros to keep their favorite proven platforms relevant. I genuinely think we will see the very first full hybrid retrofit of an Amels 180 within the next 5 years.
Because if they don't, they risk obsolescence.
Exactly. Otherwise, they risk slowly becoming the classic cars of the ocean. Beautiful to look at, mechanically pure, quite noisy, but ultimately functionally obsolete in a heavily regulated future.
Well, next time you are walking past a marina in the Mediterranean or just scrolling through Instagram and you see one of these massive white hulls, I challenge you to look a little closer. Look at the glass profile. Are the windows classic trapezoids or are they continuous modern strips? Look at the stern. Does it look like it's been stretched?
And most importantly, listen. If it is slipping away from the dock without a single sound,
Yeah.
you are looking directly at the future of naval engineering.
Thanks for taking this deep dive with us today. We will catch you on the next one.
Safe cruising, everyone!
Did you enjoy our detailed analysis? Subscribe now and join our community of yachting experts. See you in the next video.